Hello class, so we left off on this problem, this system of equations with 4 variables and 4 equations. So I'm going to go ahead and jump into it and just start solving this. So one thing we did in class was we changed this to augmented matrix form, and all that means is that we put numbers in for w, x, y, and z. So in this particular equation, we would have the numbers 1, -1, 1, -1, and 0 with the vertical line here for the values on this side of the equals. On the second equation, we have 2, -1, -1, and 3, and then -19 here. And then for the third equation, 3, 1, -2, -3, and -15. The fourth equation, -1, 3, 1, and -3, and 14. So this is how we start. Now, again, I'll kind of emphasize our goal here is to try and get diagonals in the matrix of ones, and then zeros below, and then zeros above, working our way from left to right. Now, fortunately, I have a 1 in the diagonal, just like I wanted here. Now, we do want to do some row operations to get zeros in here. So what I'll do, and I usually write them on top, but I think I kind of trapped myself here, or I can't write on top. So let's, well, I can start the next row. I'm going to do, I want to cancel out this 2. So I'm going to replace row 2 with -2 times row 1, because -2 times 1 is going to be -2, plus that will give me a 0 there. -2 times row 1 plus row 2. So we can do that. I'll also simultaneously do row 3 equals -3 times row 1 plus row 3. Because if I do -3 times 1, that's -3 plus row 3 is going to give me the 0 that I want. And then the final step I'll do is I'm going to replace row 4 with negative row 1 plus row 4, because if I do negative row 1, it's going to give me -1 plus row 4 is, well, actually, let me rethink that. It's not negative, it's going to be positive row 1 plus row 4, and that'll give me the 0 that I'm looking for. So I'm going to do those row operations. Okay, so I've completed those row operations, and you'll see we got what we wanted. We got zeros below our first one in the diagonal, which was nice because we didn't have to really move it or do anything. It was already there in the position we wanted. And the other thing that's nice is that we see that our second one is actually also in the position that we wanted. So we want to do some row operations here so that we can eliminate the zeros below there. So we're going to do just that. And what we want to do is go ahead and take out this 4 here, and so I can do this. Let's see. We can do row 2 or row 3 equals -4 times row 2 plus row 3. Okay, and that'll replace row 3, and then row 4. Since there's a 2 there, I'm going to do -2 times row 2, because that's where my 1's at, plus row 4. And that's going to give me the zeros that I want below here. Okay, so we're going to go ahead and do those operations. Okay, so we've completed those row operations. So now we have the first one in the position we wanted, the second one in the position we want it, and zeros below, and now we want a 1 in this position, but first let's try to get a 1. So a couple ways we can think of doing that. We can maybe divide by the value here, but then I see that leads to fractions, so I'm going to try and avoid that. And I notice they're off by 1, so I can just subtract and I'll end up with a 1 there. So that's what I'm going to do on this step. We're going to subtract row 4. We're going to replace row 4 with row 4 minus row 3. Okay, so we'll do that operation on this step. Okay, so now that we subtracted the rows, what we want to do is, again, the goal is to get ones in the diagonal, so I want to switch to the one with the 7. So I'm going to do a row switch operation, which will just be row 1, or I'm sorry, row 3 switched with row 4. So that's all I'll do in this step. Okay, so now that we're here, I want to go ahead and get rid of the 7 and make that a 0. So what I could do is multiply row 3 times -7, and if I do that, I'll end up with I'm going to replace row 4 with -7 times row 3 plus row 4, and that'll get a 0 here where I want it. So I'm going to do that operation: -7 times row 3 plus row 4. Okay, so we've completed that row operation, getting closer to our goal with the diagonal of 1s, but now we just need the final 1 here. So I'm going to look at this, and I'm going to we can see if we can divide it. It turns out 124 is divisible by 62, so I can just do the row operation of dividing by 62. So I'm going to do row 4 equals to row 4 divided by 62. Okay, or you could also say times 1 over 62. So either way, but I'm going to carry out that row operation. Okay, so we've successfully gotten a diagonal of 1s. Now we're going to kind of backtrack and use this one to clear out the zeros above there, using a couple of row operations. So starting with row 1, we'll replace row 1 with row 4, row 1 plus row 4, or we'll say row 4 plus row 1, and because that'll give us 0. Row 2 will multiply row 4 by -5, because -5 times 1 is -5 plus 5 will give us 0, and we'll replace row 2 with that. Then row 3 is 6, so I'm going to multiply -6 times row 4 plus row 3. And so those are the row operations that I want to do in this step, and we'll go from there. Okay, so now that we've completed that row operation, I want to use that one now to do a similar thing, clear out these and create zeros on top. So I'm going to replace row 1 with negative row 3, -1 times row 3 plus row 1, because -1 times 1 is -1 plus 1 will give me the 0 I want. And then now I want to clear out this -3, so I'm going to say row 2 is going to be +3 times row 3. It's going to give us 3 plus -3, which is in row 2. So I'm going to do that operation, 3 times row 3 plus row 2, and replace row 2 with that. So we'll carry that out. Okay, so we carried out that row operation, so we're almost there. Now all I need is this final one. So I'm going to replace row 1 equal to row 2 plus row 1. And so that'll give me a 0 where I want it, and we'll be finished with this. Okay, so we've put this matrix in what we call row echelon form, where you have this diagonal of zeros. And so basically we found our solutions. W, which is the first variable, equals -5. X, the second variable, equals 0. Y, the third variable, equals 3. And then Z equals to -2. And that solves this system. You can't see my Z there, but -2. And that solves the system. Okay, so now we have a system of 3 variables and 3 equations. This one's going to be a little bit easier than the last one. far less steps, but we'll go ahead and jump into it. We're going to set up the augmented matrix 1, 2, -5, -19, 0 for x, because there's no x value, 1 for y, 3 for z, and 9, and then 0 for x, 0 for y, and then 1 for z. And so we kind of have a lot of things nice about this problem. We already have a diagonal 1, so we don't really have to worry about that. So we'll start with trying to clear out, since we already have zeros below the first one, zeros below the second one, we'll start getting zeros above the last one. So I'm going to do the row operation to get rid of the -5. I'm going to multiply row 3 times 5 plus row 1. So, and then also to get rid of the 3, I'm going to replace row 2 and multiply row 3 by -3 times row 3 plus row 2, and replace row 2 with that. So those are the two operations that I'll be doing on this step. Okay, so my resulting matrix is here, and so I cleared out the zeros. Now I kind of want to do a similar thing here, clear out that 2 and make that a 0 as well. So the operation I'll perform is going to be row 1 equals to, I want this to be a -2 times row 2 plus row 1, because -2 times 1 is -2, plus 2 is going to give me the 0 that I'm looking for. So we'll carry that out. Okay, so after carrying that operation out, I get my diagonal zeros, or diagonal 1s with zeros below, zeros above, and I have my 3 solutions: x equals 7, y equals -3, and z equals 4. Now, with this problem, it's a lot of y'all may probably find it a lot easier to do what we did last week, which is just plug it in. But that's not what the section's about. So that's why I show the whole matrices. But we can check our work doing what we did last week, which is I would plug in the z equals 4 into the equation above, which 3 times 4, that's going to give us 12. Subtract 12 from 9, and I get -3, which is good because that's what we've got here. And then now we're going to use z equals 4 and y equals -3 into the first equation. So I'm going to do x plus 2 times y, which we found to be -3, minus 5 times 4 equals to -19. So this would give us x minus 6 minus 20 equals to -19. This would give us x minus 26 equals to -19. And then if I add 26 to both sides, I'll end up with 7 as my answer, which matches what we got here. Okay. So that solves that question. Okay, so normally I tell you guys it takes a while to get to some applications for these things, but okay, so we're at that point. It says the nutritional content per ounce of 3 foods is presented in the table shown below. This table, if a meal consisting of the 3 foods allows exactly 4,000 calories, 155 grams, and 9,000 milligrams of vitamin C, how many ounces of each kind of food should be used? So I'm going to go ahead and add in a total that we're looking for, which we want a total of 4,000 calories and 155 grams of protein, and also I need 9,000 milligrams of vitamin C in what I want. So the first thing I want to do is set up some type of equation for these for this scenario. I want an amount of food A, food B, and food C, not just for what we're used to. I'm going to just go ahead and call them X, Y, and Z. Although you could also call them A, B, and C if you want. But I'm going to call food A is X, food B is Y, and then food C is Z. Okay, so I want some value of X to set up these equations. If I know food X gives me 100 calories, that's 100 times the amount of food X, and yeah, I'm just looking here. Okay, so yeah, this is like a serving size. So some 100 times X number of servings of X plus 500 times Y plus 200 times Z, and I want that to total 4,000 calories. Alright, so some amount of food A, some amount of food B, and some amount of food Z. It's a total of 4,000 calories. So I'm going to make up a similar equation for protein, right? Because this is an equation for calories. So now we're going to do an equation for protein, which is 8x plus 14y plus 9z is equal to the protein I want, which is 155 grams. Then I'm going to make a third equation of vitamin C, which will be 250x plus 1300y plus 250z equals to 9,000. Okay, so we set this up. The next thing I want to do is get it into the row augmented matrix. So we'll just do that. 500, 200, 4,000, and 8, 14, 9, 155, and 250, 1,300, 250, and 9,000. Okay, so we've got it into the row, the augmented matrix format. So now if I kind of look at this, the numbers are kind of large. So if there's any way I can bring those numbers down, it might make things a lot easier. So one thing I noticed is that on the top row, it is divisible by 100. So I probably want to do that. So I want to do the row operation of dividing that by 100. Okay, so I want to do row 1 is row 1 divided by 100. And then I also want, I can see that the 50 goes into row 3. So I can do row 3 divided by 50. And that's just going to make the numbers a lot nicer. So that'll be the step that I'm going to carry out here. Okay, so this is my resulting matrix. Still some big numbers, but a lot more manageable. So we'll go from there. And again, what's my goal? I want to go ahead and try and get a zero out our rows here. So I'm going to zero out these. So let's say I'm going to do row 2 equals to negative 8 times row 1 plus row 2. And because negative 8 times 1 is negative 8 plus 8, that's going to be 0 in the row that I want. But also I'm going to do row 3 equals to negative 5 times row 1 plus row 3. Negative 5 times 1 is negative 5 plus 5 is going to give me the 0 that I want. So now I'm going to carry out this row operation. Okay, so now that I've carried out that row operation, I end up with this here. So one thing I can do is, well actually, let me backtrack. Give me 1 second. Okay, I got one step ahead of myself, but I corrected it. So this is after doing these row operations, I end up with this. Okay, so now the next goal is I want to kind of zero out the negative 26. Well, or I can also do the row switch. But let me zero out the negative 26. So I'm going to do row 2. Row 2 equals to 26 times row 3 plus row 2. It's 26 times 1 is 26 plus negative 26 will give me the 0 that I want here. And I think that's the only step that I'm going to carry out there. Okay, so now that I carried out that step, I noticed I have a 1 here, but I actually wanted here because what's the goal? I want diagonal 1, so I'm going to do a row switch of row 2 with row 3. That's the only operation I'm going to do on that step. Okay, so after carrying out that row operation, I find out that we end up with this here, and basically I just switched the rows. Now I'm going to look at the bottom here, and I'm going to hope that I can divide it, but it turns out you can. 685 divided by 137. But basically I'm going to do row 3. The row operation is row 3 is going to be equal to row 3 divided by negative 137. Okay, and that's the only operation that we'll do on this step. Yeah, so when I divide 685 by negative 137, I get 5. Okay, the 1 here, of course. Okay, so now I'm going to kind of work so I got my diagonal 1, zeros below. I'm going to kind of work on getting zeros above my final one. So what I would do is the row operation. So I'm going to do row 2 equals 5 times row 3 plus row 2. And then that'll be 5 times 1 plus negative 5, that's 0 right there. And then maybe I should have started with row 1, but okay, row 1 is going to be negative 2 times row 2 plus, negative 2 times row 3 plus row 1. Okay, negative 2 times row 3, negative 2 times 1 is negative 2, plus 2 is going to give me the 0 that I'm looking for. So that's the row operation that I'm doing there. That's a 1, and that's a 3. Okay, so we'll carry that out. Okay, so one more thing. We got our diagonal ones, we got zeros above. Now we just need to get rid of that 5 there, make it a 0. So I'm going to replace row 1 with negative 5 times row 2 plus row 1. That's going to give me negative 5 times 1 is negative 5 plus 5 is 0, which is, we'll clear that out. So we'll do that operation. Okay, so after all that work, we end up with this matrix in row reduced echelon form with diagonal 1, zeros below, zeros above. And our solution is x equals 5, y equals 5, and z equals 5. Or in other words, the order triple 5, 5, 5. And that solves that question.